Hi, and welcome to this quick tool review. This time around, I'm going to take a look at the Venlab digital multimeter, the VM600A, a true RMS 6000 count multimeter with a lot of extra features that you used to only find in high-end multimeters, now sort of becoming standard, even at fairly inexpensive ones. This multimeter currently is going on Amazon for $26.39 if you follow the link below. An absolutely amazing price. So the question is, what kind of quality do you get for $26.39 on Amazon with free shipping if you're an Amazon Prime member? I'd like to know. I'm always interested in how the feature creep affects the low end of the market. And it seems like even inexpensive multimeters are having features once only found in high-end multimeters, and they do a surprisingly good job very often. So let's see how this one compares. Here's the back of the box, and you'll notice they claim that it is IEC 61010-1 compliant, as well as Cat 3 600 volt compliant. So it does measure up to 1,000 volts. So I'm kind of curious to know how well constructed it is. It's comes in a simple cardboard box. Let's pop this guy open, see what's inside. So let's open this guy up. And I already started playing with it a little bit. I took these out of the bag. Came with a nice set of probes with tip protectors on it, which is kind of interesting. That seems like it's more and more common. Fairly flexible wire, not as nice as some of the really high-end fluke probes, but very workable. Claims that it's 600 volt, 1,000 volt max compliance on the wires here. This one says 20 amps. That's interesting. So the 20 amps, 1,000 volts in these probes. I'm kind of curious about that. Came with batteries, so you can get started right away. Came with thermocouple, so you can measure temperature. Now, just so you know, thermocouple is a pretty easy, temperature is an easy feature to add because thermocouple just generates a tiny voltage and they correlate that voltage to temperature. So not hard for multimeters to do, but still nice that it comes with a thermocouple. The meter itself comes in a protective case. Wow, that's a nice touch. Comes with extra fuses in case you blow some, and a manual. Flipping through the manual, it's in very decent English, very readable, with instructions on how to use each individual feature, and accuracy. And the claim accuracy is just absolutely surprising, but these days it's all done by single chip, so I guess it's not overly surprising. It's just amazing they can do all of this for such a very affordable price. The meter comes with a rubberized protection, external protection cover, I guess you'd call it. Has a magnet on the back, so it can stick to the side of something. And apparently that magnet is very strong. Easily pick this up. I didn't expect that to work, actually. So won't do it at an angle, but straight up, pick it up no problem. How about this beast? Will it pick this up? Look at that. That's one heck of a magnet. That's very impressive. I like its fact that it's got a place to store your probes in back. It also has a place to catch screws if you wanted to hang it up. On top, there's a light and non-contact voltage measurement, which we'll look into, and then the front panel. First up, we got to put some batteries in this guy. Looks like it's a single Phillips to access. I've always been curious about that because if you're in the field and you need to change the batteries, you got to have a screwdriver with you, and that may not always be handy. I mean, it's likely you'll have one, but on the flip side, it seems to me like it would be handy if it was just some sort of snap approach. Also interesting is the screw is not captive. That would have been a nice feature because if you're in the field and you pop this screw out, you're going to lose it. And this does not snap into place. So if you lose that screw, you're going to be looking for a replacement. The meter takes 4 AAA cells, and 2 of them are sort of obscured under the top part of the case. Not a problem. Also of note in the back here is a stand for the multimeter to hold it upright, which is kind of nice. Next up, just turning on the meter for the first time. It's got really nice large display, especially for my aging eyes. That's a welcome sight. All right, so first up, I'm testing the output of a variac here, which I have all the way down. I've got this on the millivolt scale, and my Fluke doesn't have a millivolt AC scale, so I assume it's less accurate there. It does have a millivolt DC scale, but this one has millivolts AC and DC. So we'll start by checking AC here, and they're reading within 100 millivolts of 100 microvolts of each other, reading 91.5 or 6 millivolts, so that's pretty darn good. And the variac's not great down at these low voltages, but let's see what we can do here as we creep up, because we're going to run out of range pretty quickly. Okay, so let's see if that settles down. 296, 295, 297, 295. It's within a couple millivolts of each other. Okay, just ran out of range. So this is a 6,000 count multimeter. So the scale, this will end at 600 millivolts, and then you've exceeded the range. So 589, and you notice the Fluke has only 3 digits. This one has 4 digits because the Fluke is a 4,000 count multimeter. So if we go down below 4 here, you get the extra digit on the Fluke. The moment you go over 4, you lose that digit on the Fluke, but this guy still retains it because it's a 6,000 count multimeter. They have much higher dynamic range multimeters, but they're a lot more expensive. You can get bench meters with, 6, 7 digits kind of thing, and then they're obviously much higher counts. So accuracy is pretty good at low voltages. Let's next hop up to the higher voltages. All right, so here we're walking up, and 3.557, 3.538, so there's like 10 millivolts different. The Fluke's about to run out of range here. So once I hit 4, the Fluke just lost a digit. This one retains the digit. So there might be as much as 13 millivolts difference right there. And that's about a 10 millivolt difference right there. And let's head up to the higher voltages. 70.2, 70.3. So now this guy just ran out of counts. It went over 60, 60 volts, so it lost a digit as well. And they're reading within 100 millivolts of each other. And that's right on the money. And we'll just crank the variac all the way up. 151, 150.7, so that's 300 millivolts of each other. So I'd say reasonably good. I mean, you're talking a $26 multimeter, so I'm sure they don't spend lots of time trying to calibrate it. Fluke's a $200 and something multimeter, so they probably take a little more care with it. So AC seems reasonable as long as you're not trying to do precision work, but then you wouldn't buy a $26 multimeter if you're trying to do precision work. As long as we're here on the with the variac and the AC variac, I forgot to put it away and I had to take it back out again. Let's check frequency. So 60 cycles perfectly. It looks like it's 2/100ths of a cycle low, or 2/10ths of a cycle low. 59.998, 59.998. And then we can go to duty cycle, which now is 50%. And I think this one has, and the Fluke says 50.1% duty cycle. It's a sine wave. It should be perfectly symmetrical, but you have lots of harmonics on the power line, so don't count on it being perfect. I did this test a couple days ago, and the frequency was 60.02. So, and actually it's measuring a little bit high now, so it varies throughout the day. Power company, the generator tries to stay on frequency, but they're not trying to hold any kind of super accuracy. As long as I have the variac out, I thought I'd do AC current, so I've got a load resistor here, and I'm raising the voltage out of the variac. I'm at about 2 volts across a 330 ohm resistor approximately. And so I've got 5.95 milliamps on this guy, 5.96, 6.0, so off by 40 microamps on that one. That's pretty darn good. This meter also has a microamp scale. Oh, there we go. Okay, there's microamp scale. 781 versus 7.079 on the Fluke. So that's working great. I keep forgetting that this meter, the Fluke, also has to switch between AC and DC. Same with this meter, you have to switch between AC and DC. And when you change scales, it automatically goes to DC. So then you got to put it on AC. And there we go. Now we got the values, so we can go up in current a little bit. There's like 11 milliamps, 10 changed, 11. Variac's really touchy down at low voltages, so that makes sense. Seems like it's working great. We can try the 1 amp range here. Okay, here we go on the amp scale, and they're reading somewhat close. I'm basically shorting the variac through the 2 meters. There's 2 amps. They measure reasonably close to each other. I don't really want to risk burning anything out here. The variac, again, doesn't work well at low voltages, so I'm loading the daylights out of it at a low voltage setting. There's 3 amps. All right, so it looks like all the scales work and the accuracy is reasonable. This is surprisingly good. All right, I've got both outputs across this power supply here, which is a really inexpensive power supply that I've looked at before. And 360, 361 millivolts. Looks like it's varying. Maybe the regulation's not so good. Both the Fluke and this think that the voltage is varying. I noticed that the sample rate on the Fluke is slower than this guy, so it might be averaging longer, or this just might be faster sampling. It does use a single IC solution that's probably, well, it is a lot newer than the Fluke, so may have faster A to D converters in it. They're reading within a millivolt of each other, so that's a good sign. Let's go up to the volt range in DC. So there's 359, 359, that's a good sign. Got a load on the output of this guy. Here's 3 volts. And I think the power supply is varying since both meters agree that the voltage is changing by around a millivolt. Oh, I'm sorry, about 10 millivolts. Interesting, interesting chase here. So they look like they're about 6, 7 millivolts difference. Let's go up. And we're 11.2 volts there. On this meter, 11.29, 11.28. Okay, 10 millivolts, 20 millivolts, not bad at all. There's full gas. And now there's about a 60 millivolt difference. Not bad. That seems good. So DC seems pretty accurate. You know, not as accurate as a Fluke, but remember again, as I reminded you many times before, the Fluke is 10 times the cost of this one. So you have certain expectations, and I think this one's performing admirably. We can do DC current as long as we're here. So, all right. So before I started this, I accidentally put too much current through this guy, blew the fuse, and already used one of the spare fuses they gave me for the low range, which is very handy. So I'm on microamps on this guy, and here's milliamps on this guy. So we're getting 59 microamps and 0.06 milliamps, essentially the same value, off by 500 nanoamps, which is crazy low. So I'm just going to walk this up just a little bit. There's 90 microamps and about 90 microamps. That's pretty amazingly good. Here is 500 microamps. 498, 498. Beautiful. Let's go up to the 500 milliamp scale here. And there's milliamps, and we're at 0.47. So we're going to take the coarser adjust here. .52, 17.56, very good. Varying by a few tens of microamps there. There's 25 milliamps. Varying by 60 microamps. That's very good. All right, so now let's go for DC current large value. So I need to move this guy over to the 20 amp spigot. I need to move this guy over to the 20 amp spigot. And we need to take the resistor out because we'll never be able to get enough current to read with the resistor in place. And here we go. So 80 milliamps, 80 milliamps. Just using internal resistance to drive this current. And I'm at the current limit here, 0.71, 0.715, and I could turn the current limit up. .2 amps, 1.243, 1.245. That's 2 milliamps on a really large scale. That's pretty impressive. So we're doing good on amps and milliamps and microamps. Very good. Next up, I'm just going to look at some capacitance values here. And I don't expect this to be particularly accurate. Among other things, I've got long probes here, and that's a huge no-no. Let's see, so this is nominally 1500 microfarads, but capacitors are often like plus 20, minus 40. And this one is not measuring anything. It says microfarads, but can't come up, might be outside its range. Oh, it's 1500 microfarads. I think this only goes to 100 microfarads. Let's see what this one does. I don't know what its range is. I'm using the same probe, so we get rid of some errors. Let's see. Look at that, 1.652, so better range than the Fluke. All right, let's try for a small ceramic cap here. Unfortunately, now the leads here running next to each other are going to have capacitance all on their own, and so that will affect the measurement. We'll try not to move anything. So let's see, this is a 0.01, and I don't know what the accuracy of this one is, the Z5U. I have to look that up. I don't remember what the tolerance is on this guy, but we're getting about 0.008 instead of 0.01, so it's off by 2 nanofarads. So 8.69, and let's see what this guy says right here. 9.7. So I can believe they wouldn't jive, but it does measure capacitance pretty reasonably and has better range than this guy over here. As a matter of fact, let me look it up in the book here. Goes to 100,000 microfarads, which is way up there. That's pretty impressive. All right, so that's capacitance. How about resistance? Okay, so I've got a 330 ohm nominal resistor here. I don't know what its tolerance is. This is some little power resistor, metal film it looks like, and it might be a precision, but I don't know. It's supposed to be 330. It's measuring 333.8 with these probes and this setup. Let's see what this guy gets. 333.8 and 333.7, 333.8. Okay, that's very comforting. All right, let's switch resistors here. This is a 5% resistor. It's got a gold band, and this is a 3K, 2.998. .00. Okay, that's pretty close, 2 ohms difference. This last one will be a bit challenging. This is a 1 mega ohm resistor, and it is a 20%, so that's within 20%, just barely. 1.2 megs. And this is a more challenging measurement, mostly because the currents are very, very small because the resistance is so large. 1.2 measures the same. Very nice. So I'd say resistance is working very well. And let's go to, I think continuity's right here. So that's great. Continuity's working great. That one, of course, works the same way. All right, so we're doing diode next. I'm going to start by putting the diode in backwards. So it tries to force a 1 milliamp current, typically that's what they do, in the forward direction. So I'm reverse biasing this diode. It should be maximum voltage out, but not enough to get leakage. So we're measuring 0 volts in reverse bias, and we are measuring 0.567 in forward bias, which is what I'd expect. That's about right, half a volt with a milliamp going through it. And the Fluke, start with going backwards. Nothing, as I expect. Forward, 0.533. So I don't know if the constant current source in this has some accuracy issues. It's very close. Let's see, 0.538. 0.571, so it's 30 millivolts approximately off. I wouldn't use this for any precise measurements. Again, order factor of 10 in cost. So let's see what they claim for the accuracy in this, but I'm not going to have an issue with that for the price of this. They don't even spec how accurate it is, and they'll feed 3.2 volts up to 3.2 volts, and yes, it is a milliamp as per spec. So that's great. We're looking good here. Let's try some non-contact voltage checks. So there's a little handheld degausser here. So let's go over to non-contact voltage check. So there's no load on it right now. So if it's trying to measure a little bit of AC current in there, I could see that being a problem. There's also twisted. So as it gets farther away, it has a harder time measuring it, but for the most part, it's finding it. So let's see under load. Once it's under load, it seems to be able to find it just fine. So that's a really handy feature. Fluke doesn't have a comparable. Degrees Celsius, I accidentally broke the thermocouple, so I can't measure that one. Pretty impressed with it so far. Why don't we take this apart and take a look inside? All right, first off, we got to take the molded plastic bumper material off, which is very flexible and feels really good in the hand. They did a nice job on that. It fits very well. Just got to pop this bottom part out and then it comes straight out. I've already had this apart before. Okay, and then the back is just 4 screws, which if you ever blow the fuse like I did, completely my fault, you'll need to get in here. The battery compartment, the batteries can stay put, and there's not a screw hidden under the batteries, which is really nice. And the batteries themselves are spring-loaded and attached to the whole battery compartment, spring-loaded to make contact with the PC board, which I will show you in a sec here. So spring-loaded contacts for the main PC board there. First thing to note when you compare the Fluke, I mean, obviously the Fluke's got a lot of extra construction features that are pretty nice on here. One thing I noted right off the bat is that the Fluke has these cutouts here, and that's for high voltage arc protection. And this guy does not have that. The Fluke also has bigger fuses than this guy. These are tiny little fuses. And it has sensing, probe sensing banana plugs on the front, which are much higher quality than these pressed metal ones. But again, 10 times the cost, so can't really fault these guys. They also have fairly large precision power resistors, and this uses small surface mount. This is much older technology than this. You'll see on this guy, you've got a single IC solution that's both display driver and all your multimeter functions. They have some probably calibrated resistors here for the input, but I'm suspecting that this mostly functions by A to D. And these resistors are just dividing resistors to get the values down where you need. So I assume they're precision. You got a full wave bridge here plus an extra diode. I'm not sure what the extra diode's for there. There's your noise generator. Your non-contact voltage sensor is just a banana plug sticking in the plastic here. And the LED for the light, which is reasonably bright, which is also another handy feature the Fluke doesn't have. Just a single LED in there, easy enough to get to. When I first got this guy, had some problems with the switch, but when I took it apart and reseated this, I was able to get the switch to work right. I had some problems in a couple different connection spots here, and you had to push on the switch in order to get them work. All right, so all in all, I think this was a great value for the money. The manufacturer responded very quickly to my problems and wanted me to send them a video so I could show them specifically how the problem manifests itself, because they said they were going to send it straight to manufacturing to make sure that it's not a defect in their design process. Now, you can't expect that someone selling a meter for 20 some bucks or 30 some bucks that it lists for is going to match a 200 and something dollar meter. Obviously, the cost of this are so much higher. These guys can't afford to spend a lot of time on it. In spite of that fact, this thing was pretty darn accurate. Now, probably not as accurate as the Fluke, but you're paying 10 times more. I was very impressed. It also has a lot of features the Fluke doesn't have, like capacitance, non-contact voltage measurement. It has the Celsius. I couldn't get this to work right, but I damaged the thermocouple, so that's on me. All in all, I think it's a great, oh, it also has microamp range, which is pretty handy. It's also a 6,000 count and this is a 4,000 count. So you get more dynamic range on this one per scale. You don't lose that last significant digit as soon as you do on the Fluke. So again, a better improvement. Now, I don't know if this is accurate enough to warrant that, but it's a nice feature anyways. All in all, I've got to say that I'm pretty impressed with the quality of this guy, and I would recommend it for the price. Yeah, I don't think you can go wrong. If you're looking for a precision bench meter, obviously this would not be your target tool, but for general measurements, something to pop in the car, measuring AC outlets in the wall, you know, simple troubleshooting, this is more than adequate. It seems to work pretty well. So I give it a thumbs up. Thanks for watching. Hope you find it useful. Hope to see you next time.